Hey folks, I'm back and I'm going to take a look at a bunch of mods for the TronXY X5SA 400. Now, I had intended to make a short series of videos covering each mod kind of incrementally as I installed it. However, I had some massive electronics failures kind of partway through the upgrades and had to do a lot more all at once. So this is going to be a lot larger of a video and take a lot more time to put together. So I will say that all of the parts that you see on this printer have been designed from scratch in the last 5 weeks or so, specifically for this printer. If you'd like to see how any of this stuff was designed from scratch, leave me a comment below. I used to do a video series called 5-Minute Designs where I kind of walked through the design process for things like this. It wasn't hugely popular. However, I enjoyed doing them. So if you have any interest in seeing how these things are made, let me know in the comments and I'd love to put one of those videos together. Now for the mods themselves, you may have already seen some of these if you watched my X5SA review video from a few weeks ago. I'll leave timestamps below so you can skip ahead to the mods that you're interested in and skip over the stuff that you may have already seen. And I'm also going to try to order these things from kind of the most impactful for the least amount of labor to the most expensive and difficult, probably for the least amount of gain at the end. Now, the first spot I want to look at are these simple little corner brackets for 2020 extrusion. Out of the box, the X5SA frame is not very rigid. It's pretty easy to shake when printing at high speeds. It's pretty easy to fall out of square if you were to move it or something like that. So adding in some kind of bracing is kind of a must-have. These are very easy to install. I prefer these 40mm by 20 brackets. They take 2 screws in each corner, so 4 screws total, and they have kind of double the surface area that a regular 2020 corner might have. So it's just a bit extra support for the same price basically. I would advise using these in as many corners as you can. Now there are some corners that it just doesn't work in because you have a carriage that has to move there or something like that. However, most of the corners on the printer can take this kind of bracket. And if not, then I do have some plastic braces that I printed for the 2040 to 2020 corners, and those will work well for the vertical braces. The second mod I want to talk about are these motor mounts and these pulley washers. Now, in a Core XY system, there are 2 very long GT2 cables that have about 6 different extents to them. And the important extents, the important runs of cable, are the ones that run up to a moving surface. So for instance, running up to this Y carriage, you have this extent coming from the motor and the longest extent coming from the other side. Those need to be perfectly parallel to the Y axis. If they are at an angle, then as the motor moves closer or further from the pulley, it will pull at a different angle depending on where it's at in the tram. Now, when it pulls at different angles, 10mm coming from exactly parallel to the axis is a different position than 10mm pulled at 30 degrees off of the axis. So you're going to get geometry errors and you're going to get tension problems as the carriage moves closer and further from the pulleys. Now, out of the box, TronXY's pulleys are on a single spindle, so they are directly aligned vertically with the pulley above or below them. This means that the Y-axis pulleys had to be pushed in slightly, so you will get a slight angle as the Y carriage moves closer to the pulleys and to the motor. The solution to this was to create a more robust motor mount that also offset the motor about 5mm out, and then a pulley spacer that moved these pulleys about 5mm in. Now, the extents leading up to the carriage are aligned, but this outside extent that runs between just the front pulley and the motor is at a greater angle on the outside. Now, in a Core XY system, this extent is a static length, so it doesn't matter if it's not parallel to the axis. As long as the pulley doesn't move, the angle doesn't matter. Now, this motor mount has some advantages over the plain acrylic mount that comes with the printer. That plain acrylic mount would bend a little bit. Now, if you have the Pro version, I believe it comes with a metal mount, so maybe that's not as much of a problem for you. However, this is a substantial mount that's not going to bend. It'll also add rigidity to the corner, and you can set the tension at the motor mount by loosening these 4 screws, pulling back on the motor, and tightening them under tension. So you don't have to try to set tension at the floating carriage that's in the middle of the printer. You just pull them back here, do the same on the other side, and now your belts are evenly tensioned. TronXY gives you a very thin, very cheap build surface that they want you to stick directly to the aluminum hotbed. That's not a good idea for a number of reasons. First of all, you want to kind of treat the hotbed with a little bit of care. You don't want to have to replace that aluminum sheet. And if you're going to be sticking stuff to it that's going to go bad fairly quickly, like this sheet, you're going to be like scratching it, scraping it up, pulling that sheet off. You may even have to remove the entire bed to really scrub it down. It's just easier if you don't apply sticky stuff directly to the aluminum hotbed. Instead, put some glass over the top. Now I'm using a 1/4 inch sheet of tempered glass because that's what I found on sale. I would recommend at least 3/16 for this size of build surface. Any thinner than that, and it could be easy to break even for tempered or borosilicate glass. And you want one of those two types. You don't want standard pane glass, especially at this size, because they will break kind of easily, especially under the heat and cool cycles of a 3D printer. Now on the one side I have a cheap piece of PEI. I generally love PEI as a build surface because it is super durable, things stick to it really easily. However, I've only used the yellow Gizmo Dorks fairly thick PEI sheets. Those were out of stock when I was putting together this printer, so I went with some of the cheap stuff from AliExpress. This is kind of the green tinted, thinner stuff. It costs about half as much as the Gizmo Dorks material, and this is not good surface. It melts under a hot end, it's easy to scratch and scar up. I would frankly just avoid this style of PEI if you went with a PEI sheet. And frankly, I'm just printing on the back on the flat glass surface, just using hairspray or school glue. So the next problem we're trying to solve with this bed is down here at the motor mounts. By default, TronXY just has a T8 lead screw attached directly to the shaft of a stepper motor. This provides very little resistance, and it's very easy to knock the bed out of balance with one motor, adjusting steps while the other one is idle. And once you add the glass into the top, it's pretty easy for the whole thing just to tram down on its own with almost no resistance. Now I have two solutions for this. One is free and still fairly easy, but takes a little time every print. And that is to print these little hats that go on top of the steppers. The idea here is that if you tram the bed all the way down until it sits on top of these hats on both sides, then you know your bed is level, at least according to the hats, the motors, and then the frame. Then, when you bring the bed all the way back up to 0 and prepare your print, you're guaranteed that it is perfectly level. Goes from the top of the hats to Z0. And that works pretty great because, as I said, with a bit of glass on top, the bed wants to fall almost all the way down to the top of the hats anyway. Now, while that's a workable solution, if you don't want to have to make sure your bed is all the way down and sitting on top of the hats and then wait for it to tram all the way up every time, the second solution is to buy one of these cabling kits. You can get both GT2 pulleys as well as the GT2 cable that runs between the two motors for about 25 bucks off of Amazon, 10 bucks or so less off of AliExpress. And they will come with the correct length of GT2 cable depending on the model of TronXY X5SA you have. My 400 came with a 1,210 millimeter loop that goes between the two lead screws. Now this worked pretty well, however 1,210 millimeters was a little bit loose and there was still a little bit of play in the cabling. And it was enough that the motors could get off by a step or two. And it wasn't terrible, it was generally workable print for print, but you would still see every once in a while on your first layer one side slightly off compared to the other. So I have a solution to that as well. I designed these more impressive hats to hold an additional GT2 pulley slightly offset to add a little bit more tension in this line. Now, there's just enough tension that generally the bed won't automatically tram to the bottom and it'll generally hold itself in place, and there's enough tension so that if one stepper is moving, you can be guaranteed that the other stepper will move as well. And since I've implemented this solution, I have not had to go through and rebalance the two motors again. It's worked every print every time. So that kind of covers what I would consider to be the easier to implement mods. Now we're going to talk about something a little more complicated, and that is my linear rail and direct drive mod. While the V-slot wheels haven't been that big of a detriment, I've actually been pretty impressed with the print quality I got out of the V-slot wheels. I greatly prefer the MGN12H linear rails. I think they're more durable. They require less overall maintenance. They don't wear down like these wheels do. And if you're talking about a direct drive that's just going to have a lot more mass and a lot more torque applied to that mass, then a linear rail is kind of the way to go. And if you're only going to replace one, and I wanted to start with one, the x-axis is the way to go. That's where most of the weight's going to be. That's where there are essentially 4 torque points that could apply twisting force on that carriage. So going with the x-axis first makes sense. So to tell you a little about the direct drive carriage, it'll pretty much take a standard NEMA 17 and anything that mounts onto the front of it. I'm using a BMG here. I started off with the Titan originally. I have blowers for both the Titan and the BMG for both the standard hot end as well as a Volcano, so you can kind of customize to your heart's content. This does have a washer to support blower fans on both sides or on either sides, and I do have mods that'll let you use the blower that came with the TronXY or these larger 20mm wide blowers. And I did extend the height for this cable chain, so the cable droop isn't such a big problem. I do have versions of the carriage that support both a BL Touch, like it's on this one now, as well as the stock sensor that came with the TronXY, or the upgraded black sensor would work as well. And then finally, it still supports the micro switch for the x-axis that came stock. It's the smaller micro switch that that's different style from a standard in-stop micro switch. Now it does use some pretty substantial GT2 cable clamps, and it's really made to clamp down on the cable in a static location and set the tension at the motor. Now one of the problems I had when designing this direct drive extruder is that when you add the linear rail, that adds height to where the carriage is mounted. And unfortunately, some of these GT2 cables are pretty darn low. So if you left the extrusion at the default height and then added the linear rail on top of it, essentially it would be at the same height and maybe overlapping a little with the bottom cable. Now I worked around that problem in 2 ways. First of all, I designed an undermount carriage. So if you mounted this linear rail on the bottom of the 2020 extrusion, I have a carriage that supports that with the motor and everything hanging from the bottom. And that's an interesting design that seemed to work well enough. However, the pulleys are all on the top of the extrusion. The center of mass, the motor and everything are at the bottom of the extrusion, so that leads to some odd torque issues as the carriage is being pulled around. And I imagine, I didn't really try it, but at higher speeds that would mean more resonance and less overall speed. In addition, you'd lose at least a few centimeters of build height, which not a big deal on a printer of this size, but if there's a better design, why not implement it? Now the second workaround was to washer the 2020 extrusion down a few millimeters so that the top of the linear rail was at the top of the carriage where the 2020 extrusion would be. And that worked very well, except for one thing. These are the pillow bearings that sit on top of the GT2 washer at this aluminum extrusion. Now, in my opinion, you don't really need nor even want these washers at the top of that rod, mainly because if you are capturing that rod in both the top and the bottom, that rod needs to be extremely straight, and that's not what threaded rods are for. They're for distance positioning, not for straightness. You have your smooth rods that keep things straight, you have your threaded rod, which sets the distance. So personally, I'd just throw these away. However, I know not everybody wants to do that. The problem with these things though, is that they are wider than 2020 extrusion. They will hang over the edge of a 2020 extrusion. Now, since this X 2020 extrusion is hanging a little bit lower than the Y 2020 extrusion, as the carriage passed by the pillow bearings, it would nip the sides of the bearings. The solution to that was to also washer these down a little bit. And I do have a washer that is only 20 millimeters wide so that it doesn't overhang, that will allow you to keep these pillow bearings if you really want to. But again, I don't think you should. I think you should probably just trash them, but to each their own. All right, so now we have a decent carriage mounted on a linear rail that is slightly lowered so that it's parallel to this the Y carriage. Everything is moving fine. It'll move in all 4 directions without any issues, without hitting any pillow washers or anything. The next problem to solve is the filament feed. So this is what's called a reverse Bowden setup, and you'll see this in a lot of large format direct drive printers. The problem is that if you just let this filament kind of free float, or maybe even guide it up to this point, as the extruder moves out, it's going to pull out a bunch of filament, and then as it moves back towards the spool, it's going to push filament back down and eventually lead it off the spool. Then when it pulls it again, it's going to get all tangled, it's going to jam, it's going to be a big pain in the butt. So a reverse Bowden setup, as this filament pulls out of the tube, there's more resistance coming back. So instead of pushing back through the tube, it just kind of winds above the extruder. So reverse Bowdens are very popular, especially on printers this size. So I have a special mount here that will take the filament sensor as well as a small PTFE tube gasket thingy and mount it directly to the frame right above where this filament would feed, as long as you mount it on the back side here. So you still get your filament sensor, you still get the reverse Bowden setup, and all is good from a filament feed perspective. So before I get into the electronics mods, I would like to state that I don't have any major issues with the electronics package that was included with the X5SA, at least my X5SA 400. The board was fast enough. You could install Marlin, you could install Klipper. It seemed to take all of my mods just fine, and it worked great until the day it didn't. Now, the specific problem that I had was that one day, the printer would just stall about 4 hours into prints. And I had printed big things, like I printed the top side of this helmet, which was 30-something hours at the time. So I knew that it wasn't something that had, that I had changed. It's one day it was printing 30 hours, the next day it couldn't print 4 hours. So it had to have been something kind of intrinsic to the board. Now the problem that I was seeing was that about 4 to 5 hours into a print, the print would just die. And both the TronXY as well as Marlin firmware would report a power outage situation. They'd come up and say, hey, look, power went out, it's back on now, do you want me to resume printing? The power did not go out. Now, when you see a message like that, you assume that the culprit is the cheap power supply that they included with the printer, so the first upgrade I made was for a Meanwell 24-volt power supply. The Meanwell power supply is a little bit shorter and a little bit wider than the stock power supply unit, so you can't use the default mounting solution with the Meanwell power supply without drilling a hole or doing something crazy. So I designed a different part that will take the switch from the default X5SA and mount to the Meanwell, and then mount that all to the 2020 railing. Now you gotta be careful when you mount this. You don't wanna mount it too far to the left, because as the bed drops, the support for the cable chain could hit your power supply. So make sure that it's kind of off by 6 or so inches from the rear right corner of the printer. Now unfortunately that did not do the trick. I still had issues 4 to 5 hours into a print. They still showed as power failures to the firmwares. Now at first glance, nothing looked too out of shape on the board. There was nothing kind of burnt out or that looked like it was having issues. Somebody online recommended that maybe the stepper drivers themselves are having under power or overheating issues, and maybe adjusting the voltage up or down on the steppers might have some effect. And I made adjustments slowly and it had a little bit of effect, but nothing that was earth-shattering. Maybe I could go 5.5 hours or maybe down to 3.5 hours, but it definitely seemed to be having some effect, so I just kept going and going and going until eventually the magic smoke was let out. So that means upgrade time. The upgrade I went ahead and went full bore at the time, the SKR 1.4 Turbo TMC 2209s. So now to keep everything together, I designed new casing, so a new housing for the SKR 1.4. I believe that'll also work on the 1.3 and the newest 2.0. New casing for the Raspberry Pi that sits on top of it. New casing for the budget LCD. This is like the standard cheap ramps LCD that you can get for $7 or something like that. I had extra ones laying around, so I thought, why not? The ventilation is slatted, so you can screw the Raspberry Pi directly into the top. The encasement supports a fan that'll blow directly over the stepper drivers, and it also has mounting spots for buck converters, so if you wanted to run 12-volt fans or power your 5-volt Raspberry Pi off of internal power, you can use the buck converters to step down that voltage. I went with the TMC 2209s because I thought that the Stallguard feature would be kind of cool, and the SKR 1.4 is kind of built for 2209s and Stallguards. I don't like Stallguard. And I don't like it for a number of reasons. Maybe it's because this printer is Core XY and not, doesn't have dedicated motors for each Cartesian axis. But it seems like whatever combination of homing speed and sensitivity I picked, there would be situations where it wouldn't work. Something would skip just a little, not a lot, but it would skip a little bit. And then you combine that with the fact that, parts of the carriage are running into parts of the frame that aren't designed to be run into. And it just kind of seems like a little bit of a janky solution. We've solved the problem of X and Y end stops. They work great. There's not a problem with an X end stop mounted here on the back of the carriage or a Y end stop mounted to the side of the frame. So why bother with all of the Stallguard business? The Stallguard diagnostic pin, the pin that tells it, hey, I'm stalling, is the same pin that is used for a physical end stop. So you cannot have a physical end stop connected if you're using Stallguard, and you can't not use Stallguard if your stepper has that physical pin present. To disable Stallguard, you either have to remove or bend the diagnostic pin on the stepper itself. Not a great solution. The SKR setup has been pretty simple, so I would not hesitate to move to the SKR board if you discovered a reason to do so. But again, I would not have moved off of the built-in TronXY electronics except for they blew up. I did not have any issue while they were running, and it's not like they weren't fast enough. It's not like there were features missing. It was doing everything just kind of perfectly until one day it started dying. Now, I will say that installing Marlin on the TronXY electronics was very easy. There's a step-by-step walkthrough that worked perfectly, no issues at all. You can use the built-in LCD. I've seen some people reporting that you can't. For my X5SA 400, with the LCD that was included, you absolutely could. There was a couple of settings you had to go in there and tweak, and those are going to be specific to the LCD that you received. But don't give up if your LCD is not working, because it absolutely does work with the touch screen using Marlin. Now, Klipper was a little bit more complex to install on the built-in electronics because the instructions weren't kind of fully up to date. To set up Klipper, you have to install a pretty generic piece of firmware onto your printer that basically just relays Klipper commands to the stepper drivers. It's a very simplistic firmware compared to something like Marlin. There's no real configurability for it. You just build it for your hardware, install it, and then everything else is handled through Klipper. The person who wrote the instructions for installing it on the TronXY X5SA included that firmware update. However, that update file that is on his page is too old for Klipper to recognize. So when you try to connect to it, Klipper will throw some errors. And then if you try to follow the instructions to build a new one, they're a little bit unclear. The part that's missing there is that when you make config, when you set up the build, you have to pick serial communications, not USB communications. Otherwise, I won't be able to talk to each other. So all the instructions are correct, except for they left out, be sure to pick serial communications when you make menuconfig. Then you'll be able to build it just fine. I'll go ahead and include my update, my firmware update in the link below. Overall, it wasn't too bad. Just you got to note that there's a little bit of nuance to installing Klipper on the default TronXY hardware. Now that concludes the major upgrades for this printer. I do have some other little nice to have items out here. There's a spatula tool holder, a plier tool holder, a razor blade tool holder over here. I have this mount for my camera and for this light bar. I'll include all of that stuff in one big Thingiverse page with links out to everything. So if you're looking for any of this stuff here, you'll have it available. So if you like this video, please leave a like. If you liked my other videos, please subscribe, and I will see you in the next one.